Hello, Aishwarya.
Hi.
Hi. So I'm Suryansh Gupta, and currently I'm working in Google since past 4 months, and I'm working in Google Cloud Security team. So today I will be interviewer. So can you give me a quick intro, and then we can start?
Sure. So I'm Aishwarya, and currently I'm a third year student at IIST Shibpur, and I study in the Department of Information Technology. I hail from West Bengal, and as for my hobbies, I have been a coder since the past 1.5 years, and I also like reading novels in my free time or listening to music. So, yep, that's it.
That's great. So let's move to the interview part. So I will share a doc with you. Uh, yeah,
Mm-hmm.
in the chat. Can you access it?
Yes, I can.
Yeah. So can you share your screen?
Sure, just give me a minute. Is it visible?
Yes. Now it's visible. So can you see me typing?
I can.
Yeah. Can you type something? Yeah, that's great. So, so I will first copy paste your problem on the doc, and then I will explain you, and then you can ask me any clarifying question if you have.
Mm-hmm.
So, so you are a bank robber with a complex security system in the bank, and there are n walls in the bank, and you want to rob these walls to get maximum money. But the security raises an alarm when any two adjacent walls are robbed. So
Mm-hmm.
you are like you are given the amount of money stored in each n vaults, and you have to find the maximum amount you can rob. So for example, if these are the money which are stored in the vault, that is
Mm-hmm.
10, 7, 9, 3, and 10, then the maximum amount you can rob is, without raising the alarm, is 10, 9, 10 plus 9 plus 10, that's 29. So that's it.
Okay. So one thing that I wanted to ask is that since you said that the vaults contain some amount, so can that amount be negative or is it always going to be a positive value?
Yeah, so to be practical, those value will be positive. It can be zero, but it can't be negative.
All right. Mm, so I guess for this question, one very easy way I can see to solve this is using a brute force recursive approach. So, like we can just code the question in its exact terms. So, like how they have said it, they have said that if we take one house, we can't take the next house. So, we can do the same thing in the recursive solution, that we will have a function that calculates the maximum. And each time it's going to call itself twice. And once it's going to calculate the maximum using the current value plus the house that's like two steps away from it. So if like we are currently at the first position, so the current value plus the maximum we can get using the sum from the starting from the third position itself. Or
Okay.
the second call is going to be leaving out the first position. It will directly calculate the sum starting from the second position, and then using those two values, we can return whichever is the maximum.
Okay. Okay. So this looks good to me. So can you tell me the time and space complexity of this?
So we aren't really using any space. So I guess extra space. So we can use O of one for the space.
Mm-hmm.
And as for the time, since we are using a recursive approach, so it's like at each point we can either consider the house or we can leave it and move on to the next one for finding the maximum. So at each point we have two options. So I guess for time it's going to be O of 2 to the power n.
Okay. So for space, you said it's constant. So are you considering the recursion stack also?
Nope, nope, nope. I did not consider that. So I guess if we do consider that, then we will have O of maximum O of n for the stack.
Okay. Okay. So can you explain me like why it's O of n?
Because like at a time when we are calling the functions recursively, so like the stack can like keep building up until we reach the end of the array. So considering
Okay.
that we are not going to leave out any house in the worst case, then it's going to be the stack is going to be as large as all the elements inside the array, so it's going to be of n.
Okay. Okay. Yeah. This makes sense to me. So can you like try to optimize this solution or find a better solution?
Can I get a second to think?
Yeah. Sure.
So I think instead of using a recursive approach, we can use an iterative approach to solve this problem,
Okay.
because I can see that we are like repeating some steps again and again when using this thing. So like one thing we could do is use memoization with recursion. So that's going to be kind of similar, or that, or we can use an iterative approach for that. So using DP, I guess.
Okay. Okay. So like can you elaborate your solution a bit more?
Yes. So if you are using the iterative approach, then I guess we can keep a vector to like store the maximum amount of money that we can rob until a current point, and like that is going to be equal to, like, the state for that DP is going to be equal to the maximum sum uh, we can get till the last point, or the sum that we can get using the current value and the second last point. So whatever
Mm-hmm.
was the sum until the second last point and the current value, that's one option. Or directly the last step we came from without considering the current value. So there can be two options for
Okay.
each point.
When you say until like what is the starting point in that case? Like from where till until?
We are going to start with the points 0 and 1 itself. So like
Mm-hmm.
considering an array where there are just two elements. So can I like take an example?
Yeah. Sure.
So considering that there are just two elements, so the answer is going to be either 9 or 5, either the first element or the second element. So
Mm-hmm.
like in that case, we can initialize DP of 0 as array's zeroth value,
Mm-hmm.
and DP of 1 is going to be array of 1, and the
Mm-hmm.
answer is going to be whatever is the maximum of DP of 0
Mm-hmm.
or DP of 1.
Okay.
And starting from there, we can build up if there are more elements inside that. So anything, any random values. So
Mm-hmm.
here, like 6, when we are considering the second element, the
Yeah.
third actually, second
Mm-hmm.
position, third element. So then
Mm-hmm.
we'll consider the first value. When we are at the
Mm-hmm.
fourth position, we'll consider the second value. When we are at the
Okay.
fifth position, we'll consider the maximum until the third value, and we are going to keep building up until the end.
Okay. So can you write the state transition state also, like transition of the DP also?
Sure. So it's going to be at any position, it's going to be the maximum of either the last element. So we are
Mm-hmm.
not considering the current position. We are not robbing the current vault,
Mm-hmm.
or we can rob the current vault. So ARR of I plus DP of I minus 2. So the maximum till the second last vault plus the current value,
Okay.
either of the two.
Okay. Okay. So this makes sense to me. So can you tell me the time and space of this?
So here we are just using one array for keeping track of the maximum amount.
Mm-hmm.
So I guess space is going to be O of n.
Okay.
And for the time, we'll just need one loop to calculate the maximum from the starting till the ending. So considering that all the elements are accessed once, it's going to be O of n once again.
Okay. Okay. Uh, yeah. So this makes sense to me. So you can move
Mhm.
ahead to the coding part.
Mhm. All right. So, like when I'm assuming the function for the input,
Mhm.
can I assume that the entire sum is going to fit within an integer, a 32-bit integer?
Yeah, you can assume that it will fit in 30-bit.
All right. So, anti max robbed. And I can assume that we have a vector of integer as our input.
Yeah.
So, vector of anti ARR. And so, at first, we are going to take the size of the array,
Okay.
and there's going to be a maximum value, and since it can fit within an integer, so I'm initializing it as anti. Next we are
Mm-hmm.
going to keep a vector for the dp states, vector of anti dp.
Okay.
Size will be as that of nums, and we'll initialize it with 0,
Mm-hmm.
and dp of 0 is going to be, oops, it's going to be array dot size. So dp of 0 is going to be array of 0, and maximum will be array of 0 once again. So one case that we could probably have is that the array size is just 1, right? That
Mm-hmm.
could be a possibility.
Mm-hmm.
So in that case, if um n is, can n
You
also
can,
be 0?
yeah, there can be no vaults in the bank.
Okay, okay, okay. So in that case, if n is equal to 0, then in that case, are we simply going to return a 0? I guess,
Yeah,
if there are
as
no
we
words.
can't rob any money, so that's zero.
All right. Um, if n is equal to 1,
Mm-hmm.
then we are just going to return the maximum value, which is equal to dp of 0. Else, we are going to have a dp of 1 is which is equal to array of 1, and we are also going to have maxi equal to max of dp of 0 and dp of 1. So now we can just run a for loop for int I equals to 2, I less than n, I plus plus, and here we'll just have the transition state. dp of I is going to be maximum of dp of, oops,
Yeah, you can keep doing. I'm just arranging
okay.
the line spacing.
dp of I minus 1, or we can take dp of I minus 2 plus the current value. And when we are done, I guess we can simply return dp of n minus 1. Yep. Let me check my code for a second, if it's all right. So if we take this example, I'm copying it.
Mm-hmm.
So dp of 0 is 10, dp of 1 is 7, dp of 0 is 10, dp of 1 is 7, dp2 will be equal to 7, or 10 plus 9, 19. dp3 will be equal to 19, or 7 plus 3, 10. So once again a 19. dp of 4 will be 19, or 19 plus 10, 29. So the answer is 29. Yes, I guess this looks fine to me.
Yeah, this looks fine to me. Some just nitpickings. Uh, if you know that the n is zero, so does it make sense to make a DP array of zero size?
No, it doesn't. Yes, we can put it after the if else.
Yeah. Uh, Also, like if you are making the DP of array dot size, so like if you already have calculated array size in the variable n, so shouldn't we use it?
Ah, true. I forgot about that. Right.
Yeah. So this looks good to me. So I have a follow-up problem for you. So
Mm-hmm.
now, like seeing your robbery in a bank has like increased the security, and now they have connected first and last vault also. Like connected by mean that the raising alarm mechanism will consider them as adjacent. So
Mm-hmm.
if I take the same example, uh, then I guess the answer for this one will change. I guess you can try yourself that. Oh, sorry, you can try yourself that like what will the new answer if I impose the next condition.
So we can't use the first one with the last one.
Yeah. So
Mm-hmm.
it will better if I can explain you, give you the answer
Mm-hmm.
for this one to save time. So the answer for this one will be 19. As like if I am taking these this 10 and this 9, then it gives me 19. And the other possibility which I have is taking this 10 or this 9, and this again gave me 19.
Mm-hmm.
And I can't take this 10 with these 9 and 10 because these two tens are connected and these two are adjacent. So
Mm-hmm.
does it make sense to you?
It does. It does.
Yeah.
Hmm. So I guess we can like consider breaking the entire array into two parts. Like,
Okay.
since you said that we can't consider the first element with the last element, so like
Mm-hmm.
that's the only extra constraint. So we can break the array into two halves, one that will exclude the last element and one half will exclude the first element.
Mm-hmm.
And then we can like separately calculate the maximum values from the two, and then we can return whichever is the bigger answer. So
Okay. Okay. So can you tell me the time and space for this?
I guess we can use the solution similar to we used in the first part. So
Mm-hmm.
we can do it iteratively. The only thing is that I guess we'll need two separate arrays. I guess we can use the same vector. We can just introduce an extra state for that.
Mm-hmm. Okay.
Uh, so like currently we have a 1D array. So
Mm-hmm.
in this case, we can make it 2D,
Okay.
and the second dimension will indicate whether we are using the first vault or we are leaving it out.
Okay.
So we can use dp of whatever is the current position and then a 0 or 1. So 0 is going to indicate that we did not use the first vault, and 1 is going to indicate that we used the first vault.
Mm-hmm.
And in that case, while we are calculating the values progressively inside the loop, we
Mm-hmm.
can just keep sure that when we are returning the maximum, we are either considering the last element sorry, I mean we are considering the last element with the second last element, and second last element when we have not considered the first vault. So I
Right.
guess when we are considering array of n minus 1, we are
Mm-hmm.
going to consider dp of n minus 3 0 with that.
Okay. Okay. Can you just write it
And
like it will make more sense to me?
yes, so there can be three options. We are going to return the maximum of the last cell
Mm-hmm.
plus dp of n minus 3 and 0. So
Mm-hmm.
this is the second last value, and we haven't considered the first vault, so it's
Mm-hmm.
safe. Either that, or we can use dp of n minus 2. That is, we are not considering the last vault.
Mm-hmm.
So when we are not considering the last vault, we can either consider the first vault or we can leave that out. So whichever gives us the maximum answer, doesn't
Mm-hmm.
matter. We can use both of them.
Right.
And this is going to be, there's going to be another max for this. So yes, this.
Okay. Cool. I guess then your both the solution makes sense to me. So what will be time and space for this one?
So for the time, we are just going to run the same loop. So it's still going to be an O of n. For
Mm-hmm.
the space, however, it's going to take O of 2 into n. So I guess that's
Yeah.
not going to affect the space. It's going to still stay an O of n.
Mm-hmm. Cool. Cool. So this makes sense to me. So can you tell me like which solution you will prefer, this one or that one? Like the
Mm,
one with two states or the one with calling the DP
the same
twice?
thing twice. Yes, I guess we can use the first one. It's a bit simpler, where I guess we can like keep two separate DP arrays, and one is
Mm-hmm.
going to like calculate the it's going to calculate the situation where we are considering the first half and
Mm-hmm.
excluding the last vault, and
Mm-hmm.
another DP array that's going to consider the second half and exclude the first vault. And we can
Okay.
simply take the maximum of the last elements of those two vaults. So I guess that's going to be simpler to like understand for someone who is seeing
Mm,
the code for the first time instead of using this complicated DP state.
yeah, right. It makes sense to me. Even I can suggest you that like instead of having two DP arrays, like writing it in the code, you can reuse this function and like call this function two times with two different initial arrays,
Makes
right?
sense.
Yeah.
Mm-hmm.
So I would not like you to code this up as like it's completely same as previous. I have another
Mm-hmm.
follow up for you. So now like seeing your robbery again, like they are increasing the security even more. Now they're
Mm-hmm.
moving the vaults to some rooms, and like those rooms are in kind of a tree structure. So now again like the restriction is uh, kind of same. If you're taking a if you're robbing a vault in a room, you can't rob the two children of those room. So it will be a the rooms will be in the form of binary tree. uh,
Mm-hmm.
for example this. So like if the first room contains a vault with value 3, and like there are two rooms connected with this one is left and another is right, and one has two, left one is uh, 2 and right one has 3, and then for the left one it contains another room in its right, that's 3, and then for the right one it contains one other room in
Mm-hmm.
its right, that's 1. So for this one like you want to rob the maximum one, and like I can say that the maximum which we can rob here is 7, and we can rob this by like I'm going to color it. Should take this 3 and this 3 and this one.
Okay, so like the immediate root and the two grandchildren.
Yeah.
Makes sense. So one thing that I would like to ask here is that when we are moving from one room to the other, is it like we can like move in from both ways? So like in this middle two, can we like move in from both the threes on the two ends, or we can just move
No,
in
like
from?
it's kind of a T, and like you can only enter from the root one. That's the first
Okay.
room, and then you can only move ahead and rob. And
Mm-hmm.
on the root one, you will break the wall and you will get free.
All right. Okay, give me a second.
Okay, can you can try thinking loud so that I can understand
So
it.
I am trying to like think along the lines of the very first question you gave. So like
Hmm.
the way we used recursion in that one, I guess we could use something similar here,
Okay.
except for that. In the first one, we didn't have a lot of like branches to consider about. Here, it's going to be a little more complicated. So I guess we can use a similar recursive approach. So
Hmm.
we can start off with the root, and then inside the recursive call, we can like consider the root along with the grandchildren. Either that, or we can skip the root and then we can call the left and right grandchildren successively and then add them up, and then we can take the maximum of either of the two choices.
Okay. Okay. So that's that looks good to me. So can you tell me the time and space complexity for this?
So once again, it's similar to the very first approach. So if
Hmm.
we are considering uh, two recursive function calls at each level, the
Hmm.
time is going to be O of 2 to the power n, because we can consider each of the node, or we can leave it and move on to the children for considering them
Hmm.
in the maximum amount. And
Hmm.
for the space, I guess, mm for the space, I guess it's going to be O of h for the recursive stack, where height h is going to be the maximum height of the tree.
Okay. Okay. Hmm. So this makes sense to me.
Mhm.
But can you try optimizing it?
Hmm. So similar to the first problem, we are like repeating things again and again. So like we can use memoization along with the recursive calls. So that's going
Hmm.
to speed things up,
Okay.
I guess. So for
Okay.
that, I guess we can keep a map and keep track of all the maximum values we are getting at each point. And in the function during the recursive calls, if we encounter that node again, we can simply use
Mhm.
the value stored inside the map and not use the recursive functions within it again and again.
Okay. Okay. Uh, so can you tell me like why you used map for the DP and like what do you mean by map? If I don't know about a specific language.
Uh, so a map is like sort of implemented as a red black tree. So
Hmm.
it's like you can insert things and you can use it to keep pairings of a key and a value associated with it. And whenever you need to search that key up again and the value associated with it, you can do it in a very small time. So like it's going to save you a lot of time when
Uh,
searching up or inserting.
so can you
So
quantify this small time in terms of?
yes, for the maps, I if we use a map, then it's going to be log n for everything. For insertion, for lookup, everything is going to take log of n time.
Okay. 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 So this makes sense to me. So can we use anything better than map? Like by map, I guess you
Mm.
meant self-balancing binary tree, I guess.
Yes, yes, yes. So I guess we can use an unordered map, because like we generally implement unordered maps using normal hash tables, and
Mhm.
the time complexity for insertion and lookup is O of 1. But I'm pretty
Mhm.
sure we can't use unordered maps with structures like tree nodes. So like if we had something
Mhm.
simpler
So
like
are you talking about
integers.
are you talking specifically about a language? Because I guess we can do in some languages.
Yes, yes, yes. I generally use C++ for my coding. So in C++, the maps don't work with tree nodes.
Hmm. I guess another map.
Yes, yes, unordered maps.
So can we make it work like there's no provision of doing it like or we have
We
anyway?
can we can implement it by ourselves. Of course, we can like implement a structure like an unordered map that can like store it
Mhm.
and then look up the thing. But then we'll have to like write a hashing function and stuff like that on our own. So like I can do that. Is that required right
No,
now?
I guess like it's not required for now.
Mhm.
And as I'm telling that like other languages have that support. So if you use Python, then like You don't need
Yes,
to
it's not
implement it.
necessary. Mm-hmm.
Yeah. So this makes sense to me. So you can move ahead to the coding part. And I will like you to write the time and space for the next solution also, and then you can move to the coding part.
For the time, I am pretty sure that the memorization is going to reduce it from the exponential call.
Mm-hmm.
But there's going to be an extra requirement for the map usage. So I guess for the map, I guess maximum we are going to call up all the like look up all the tree nodes at most once, because like if we have already encountered that somewhere, we are simply going to use the map for that.
Mm-hmm.
And so I guess this is going to be O of n for all the calls to the nodes, and an
Mm-hmm.
extra log n for using the map. So like within
Mm-hmm.
each function call, we are accessing the map again and again, so that will take log n time. And
Mm-hmm.
for the space, it's still going to be of h, because maximum it will reach up to the depth of the tree.
Mm-hmm. So I'm not considering the size of the map for the space.
Mm, yes, I guess we'll have to consider that. So for that, it's going to be O of h plus n. So I guess whichever is bigger is going to get considered in this case.
Uh-huh. So do you think we have
Height is
a
going to be smaller in
yeah,
all cases.
yeah.
So of n.
Okay, so I guess this time space complexity makes sense to me.
Mhm.
Also, can you uh, tell me what if we are using an ordered map with a proper hash function? If we have, then what
Yeah,
is the time?
in that case, the time is going to be simply O of n. There's not
Mhm.
going to be an extra log n for that. And space
Okay,
will remain the same because we are still using a map for that.
cool. So this makes sense to me. So as you're
Mhm.
coding in C++, you can use normal map for implementation.
All right. So let me copy this signature.
Yeah.
Okay, so now in this case, I don't think there's going to be a vector. Instead, I guess I'll
Mhm.
have a tree node.
Yeah, you can imagine a tree node that will contain attribute called say value that will store the money stored in the vault, and then
Mhm.
it will store uh, two pointers to the same tree node, having left and right, storing that
Mhm.
if they have a left room or right room or not. It will be
Mhm.
null if there is no room, and it will be the address of the next tree node if there is a room.
All right. So here I'm considering something like this tree node start root,
Mm-hmm. Mm-hmm.
and so each root is going to have maximum value for the left child. So this can be max left, and maximum value for the right child. So max right. And I guess we can use a map. So map of tree node star and tmp. Mm, I guess we can name it something better.
Mm-hmm. Yeah. I guess similarly we can name that DP array also some better.
DP. Yes, yes, yes.
Yeah.
Should I go and change it? I guess we can use the name max curve value. That
Oh,
makes more sense instead of DP.
yeah, it's fine for now. As you said, it make more sense. So you can move ahead to this
Mhm.
this code and you can name this.
And we are going to send it to a function. So this is simply going to return um max robbed, and this is going to be max sell, max write, and max per value. So here we are going to have the max robbed.
Can we have function with the same names?
I guess we can, but we are overloading it, so that shouldn't be an issue.
Okay, okay.
Like if you want me to, I can change the name, but there's not going to be an issue because the parameters are different for both of them.
Yeah, it makes sense to me. Like if they are in a class, yeah.
Mhm.
But I will prefer that you should change it because, like, say if they are not in a class, or say
Mhm.
I'm using as a global functions.
So just for differentiating both of them.
But I guess you can name it max robbed helper because like that will make more sense to the use case
Mhm.
also. As like I don't have anything now to differentiate between these two functions.
True, true, true. So this will be tree node star root and the and max L max right, and there's going to be a map of tree node star and the max per valid. So at each point we can, if the value is not 0 for the current root, which means we have already found the value, maximum value we can get with robbing this root, we can simply, it's not equals to 0, we can simply return MP of root. And
Uh,
if also if the current, okay, let's come back to that later. Otherwise, we are going to have a maximum left grandchild. We are going to have, okay, left, it should be LL. Maximum LL grandchild, maximum lefts right. So that's going to be LR grandchild. There's going to be a maximum of right and right, and also a maximum of the left child of the right root. Oops, right, left. So these four, we can also initialize them to 0. So once we have these four values, so now max L is going to be equal to max robbed helper. And we are going to send root of value and plus whatever is the max LL grand plus max LR grand plus, oops.
Can you like also tell me the reasoning behind these transitions?
Yes. So here currently we are trying to find the maximum value we can get for the left child and the maximum for the right child. So in this case, for the left child, it's going to be when we are considering the value of root. Like for example, here we are considering the value of root plus the maximum of the two grandchildren, the four grandchildren in all. There are four grandchildren for each of them.
Right.
So we are considering all of them, and that's the maximum we can have for both left and right. So we are going to call this function twice. There's going to be a max L and a max right. And once we have those two values, we can okay, I did a mistake. For the left, it's going to be max of root of left plus. So for the left side, we are sending the left child and the grandchildren. For the right side, we'll send the max robbed helper.
I guess you put
Oops, I
plus
did
instead
not
of
finish
comma.
this. Uh no, it's okay, sorry. Yes, this is going to be comma.
That doesn't make sense to me.
Mm. So this is for the left child. So like for the left child, it can be either the left or the, okay, I did. I'll also need to send the map.
Yeah. Also, you're sending 4 values, but I guess that is function description contains only 2 values, right?
Okay. Sorry, when I was talking to you, I just forgot. I'll need to just send the left values for this. I thought I had shifted to the next line, so I wrote the
Okay.
right part also. Also, what was the name of the map? Max curve value. And for the max right, it's going to be equal to max robbed helper root of right and max RR grand, max RL grand, and max per value.
I guess you missed underscore.
Right. And once we have like this is going to return us the values for the left and the right child when we have not considered the root.
Okay.
So once we have these values, we can now set the value inside the map. It's going to be the maximum of root of value plus all these things. So I guess I can just copy and paste this. So root of value plus the 4 grandchildren, maximum of LL grand
Okay.
plus LR grand plus, and also because I'm sending them in reference to the function, so they are automatically going to get changed once all the function calls have been done with.
Okay. Yeah.
So these are all the changed values, either this or the values we have for max left and max right. So when we are not considering the root, let me put a bracket for this. So these are going to be the two options for the maximum. And
Okay.
once we have set it inside the map, we can simply return this. And if we are, for the base case, if we are considering a root that is null, like we have reached the end of the tree, then we can say that he has not robbed anything. So we can simply return a 0.
Okay, but can you explain the last part? Like, I'm a bit unsure about it. Like, what are the cases we are? Like, one is I'm considering myself, and then four of my childrens. And what is the next one?
The left and the right child, without considering yourself. Suppose you are in the root. So
Oh,
without considering the root, you are considering the sum of the left and the right children. The maximum sum you can get using the left and the right children.
so these left and right are my left and right.
Yes, exactly. The left and right of the root. That's what I've sent. Like max L is equal to max robbed helper root of left. And then the, like this function is once again considering which is going to the maximum, the left child or the grandchildren. Like when we have moved to the left child, Once again, we are going
Mhm.
to consider the grandchildren also, because the maximum can be without considering the left child. So
Okay.
this is what I'm
Okay.
doing here, and then I'm simply adding them up, because like if you are not considering the root, you can consider the sum of both the children in the next level, immediate next level.
Yeah, true. That makes sense. So that maxl and maxr are the like best we can have if we are
Not
considering.
using the root and using the immediate level, next level.
So I wanted to hit it. Oh, yeah, that makes sense. Uh, so like this seems fine to me. Some small nitpickings. Like what if the case like I told you that like there can be zero money in the vault also. So for that case, like a node can have a zero as it max, but you're checking. Like I guess this check is for that if this state is already calculated or not in our DP.
True, true, true.
So I guess like it doesn't differentiate with that. It won't create any problem, but it doesn't make sense, right, to like have this like this. So can you suggest anything better for this, or like how we can avoid this?
I guess there's a find function also inside map. So
Yeah.
instead of using the not equal to, we can simply use the find function for this.
Okay. Can you change it?
Yes,
I'm not
I
sure like if you know or not. There's a count function also. I guess that will like help you to write less, even less. Uh,
which function did you say once again?
Count
Oh, yes, right.
that
Yes,
returns
yes, yes.
zero or one, like it
Count will be,
contains.
yeah, 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 0.
Yeah.
Both
So
works.
this also fine. Like uh,
hmm
this makes sense to me. So yeah, like
Let me just do a small dry run uh,
yeah, sure.
to see if this works or not. So for this case, let's consider the example that you gave.
Mhm.
So we are starting with 3. So for the maxel, we are sending 2. For the right side, we are sending 3. Again, for 2, we are sending 3.
Mhm.
Left side
You can
returns
try
a
doing
0.
it on the dock if you can.
Mm, it's going to be a bit hard considering I don't have a tree structure with me. So for 2, it's going to be a 3 and
Mhm.
2. For 3, it's going to be a, what was it again? 3, there's just a 1. 2, there's just a 3. So for 2, we get returned a 0 from one side and the 3 from the other side. Similarly, we get returned a 0 and a 1. So on the second level, it will be max L is going to be maximum of 3 plus 0 plus 0. The right side will be, copy the tree here.
Yeah, sure. You can. So can you tell me like what you're writing? I'm not able to like get this right. Like these are.
Like, oops, I made a mistake. So for the 3, it's going to call 3 and 2, and for 3
Mhm.
and 2, there's going to be just one call, because one of the sides is going to return a 0
Mhm.
and the other side is going to return the value itself. So 3 and a 1 for both of them.
Okay.
Uh, Once we have this, it will move one level up. Like
Mhm.
for 3, the maximum value is going to be maximum of 1 plus grandchildren is 0 and current value. So it's going to be 3. For 2, the maximum value is going to be 2 plus whatever is the, okay. So it's going to be a 3 once again.
Mhm.
Mm, So when we are coming to the top, we can either use these two values. Let's use it here. When we are coming back to the top, we can either use 3 and a 3. That's going to give us a 6. Either that, or we can use a 3 plus the direct grandchildren. So 3 plus 1, 7. So it will compare between 6 and 7, and 7 is greater. Okay, right. Right, it will give the correct answer.
Okay, yeah. So this makes sense to me. So I guess like we are done. We can end the interview. Okay, thank you. Like if you have any question, you can ask me.
No, I already took a lot of time, so like it's
Yeah.
fine.
Cool. Thank you.
Yes,
Bye bye.
my pleasure.